Now let's look at quicksort big O. Let's bring up our list here. So the first step with quicksort is to run pivot. When we run pivot, our list ends up looking like this. And if you'll recall, in the pivot function, we had a for loop that went all the way through the list looking at each item. That process of running pivot is going to be O of n. But the recursive part, we've done one step here. Here's 2 steps and 3 steps. So let's say we have approximately 8 items here, and we did this in 3 steps. 2 to the third power is 8. We've seen this before. That's O of log n. So quicksort is O of n times log n, just like merge sort. And on the graph, that is much more efficient than O of n squared. But the n times log n for quicksort is actually just for the best case and the average case. The worst case is not n times log n. So let's take a look at that. Our worst case is if we already have sorted data. So we start out with our pivot point being that 1. We're not going to move anything else in the graph, and that one is going to be sorted. And normally we run quicksort on everything on the left and everything on the right. But we only have items on the right. So we're going to run pivot on everything else again. Remember, pivot is O of n. So we're going to do this again, and then we're going to do it again all the way down. So we're running that pivot function on every single item. So that O of n function pivot, we're running it n times in order to get this sorted. In other words, this is O of n squared if you have already sorted data. So O of n squared is actually the worst case with quicksort. So long as you don't have sorted data, you know you're going to have data that is very out of order. You can count on it running in n times log n times. But if you have sorted data, it might be better to use something like insertion sort. So we saw earlier that insertion sort is generally O of n squared, but the best possible scenario for insertion sort is O of n. So that becomes one of the things you have to consider when you're looking at sorting algorithm, big O.